Hello, this is the fourth video of a polar coordinate series for OCR Pure Core Further Mathematics, and it looks at finding areas enclosed by polar curves. You should be familiar with the formula for the area of a sector, being A equals half r squared theta, where theta is measured in radians. Then consider delta A, where we have a curve and we want to measure little bits of area of it. And we can do this by looking at small areas, sector areas, where this is delta theta, and we have r and delta r. So then we say that that small bit of area must lie between half r squared delta theta and a half of r plus delta r squared d theta. If we were to sum those in the limit of both delta theta tending to 0 and delta r tending to 0, then we would in effect integrate. A more formal proof can be found in your textbook or online. So the area enclosed by a polar curve, such as shown in the example here, can be thought of as a sector with variable radius, and depending on the values, say alpha and beta, of theta between which we want to integrate, these then would become the integral limits, remembering that they must be in radians. In this example, we're asked to find the area enclosed by the polar curve r equals sine theta between theta equals pi by 6 and pi by 3. So the area will be half, taking that outside, and then the limits pi by 6 and pi by 3 of r squared d theta. And we know that r can be written as a function of theta, so we replace that and note that it's sine squared d theta, which we wouldn't find particularly easy to integrate. Luckily, we have double-angled formula that we can use, and because when we're looking at areas enclosed by polar curves, we're dealing with r squared, then we'll often have functions that we need to use double-angle formula for. So I'm going to take another half outside of the integral. It's your choice as to whether you do this or not. And then that becomes 1 minus cos 2 theta d theta, which when we integrate it will give us theta minus sine 2 theta over 2. Putting in the values, this would give us pi by 3 minus root 3 over 4 minus pi by 6 minus the root 3 over 4. Those values will cancel out, and then multiplying that gives us pi by 6, multiplying by that quarter gives us pi by 24 as the area. It's always useful to sketch a graph to check that the answer looks sensible. You can also check definite integrals on your calculator. So remember that when you've got this r squared function, if it happens to be a trig function, which often they are, you will need to use double-angled formulas in order to then integrate these type of terms. This is the last video for the polar coordinates series.